Assalamu alaikum. My name is Muhammadin. Today we are here to present our FYP. There is paper robot as a receptionist at Sukkur IBA University. Our supervisor is Dr. Suresh Kumar and co-supervisor is Dr. Asif Khan. We are two members, Muhammadin and Shakir Ali. So let me give you the introduction about my FYP. As we can see that robots have earned huge popularity in modern world. Robots are everywhere in industry, in hospitals, in educational sectors, and in many social environments. And one of them, the category of the robot is humanoid robots. And among the category of humanoid robots, the paper robot is the one which has earned huge popularity in modern worlds. It's because based on its behavior and its structure, there is humanoid and kind of uniqueness that attracts the attention of common man. So here are certain features of our paper robot. It has tactile sensors and its weight is 28 kg. It has lithium ion battery and it has sensors in head, chest, hands, legs, and it has also camera which which captures the images from the environment, and based on it we can implement certain machine learning algorithms to detect the objects and also to detect the faces of the humans. It has also wheel type structure through which it can move, and it has display screen on its chest, and through it we can display multiple things required. And let me tell you more about paper. Paper has become a platform of interest worldwide in variety of other applications, and it's implemented as a receptionist at certain points. We can say in South Korea and also other developed countries, and it's also working as a teacher or a guide. And in certain hotels in foreign countries, it's also working as a waiter, caretaker. So here is what we found, that in North American airports, these robots greet the travelers and guide them if needed, and also answer the queries required. And they also work as they offer menus and certain recommendations. In UK, they are working as a receptionist at several offices, and this is also Project Keresis, an international team used paper robot as a caretaker. The project won more than 2 million euros with donors including the European Union and the Japanese government. So it means it has variety of the application in modern world. So we are using it as a receptionist at Sukkur IBA University. So what are our aims and objectives? Let me make you more clear about it. So what we are going to implement in this FIP. So our main aim is to implement it as a receptionist. And what are our objectives? The first is that the robot welcomes visitors and provides information about the university, such as departments, programs, events, and admission processes, and certain other queries. And the second objective is that the robot will be able to provide the information about faculty, about staff available at Sukkur IBA University. And the third objective is that face recognition and detection, because if our robot is standing at the gate and welcoming certain visitors and some of them may be known, we can say that there is our own employee such as VC talking with the robot, and the robot should be able to detect the face and recognize the face and greet certain employees of Sukkur IBA University. And that is much necessary if a robot is able to recognize the face, and it loads the conversation related to that. And our fourth objective is improving the existing speech recognition system of the robot, because the existing speech recognition of the robot is not well enough, because it has the accent related to American, or we can say British, but it doesn't recognize well enough the local accents. of our local common people, because what we speak, there is the Asian accent of the English, and that is much different from American or British accent of the English. So aim was to improve the existing speech recognition system of the robot. So here is our first and second objective, that how we have achieved. So the first object that was about developing the dialogue box, first and the second, it was about entertaining the queries related to university and entertaining the queries related to what we can say faculties available at Sukkur IBA University. So it is mainly about dialogue box, and that is about the university, departments, programs, events, admission processes, and the robot is able to provide the information about faculty, staff, and there is also general talks. So how actually this dialog box is working is there is input voice that is converted from speech to text, and then it is analyzed. Analyze means what the user or what the visitor is saying, to analyze it in the memory. And then again, if its response is generated, then that is converted from text to speech, and the response is given to the visitor. So this is how this dialog box is working. So here are our results, or we can say the outputs. So the first screenshot is showing that how the information about faculty is displayed, how the robot responds. If it is about the first image shows the list of the HODs available at Sukkur IBA University, and the second screenshot shows the information about Dr. Fahim Chacha. And here is the video that I can show you as a sample. So there is a query asked from the robot, and the robot replies accordingly. So simply the query was about who is Dr. Fahim Ahmed Chacha.
Dr. Abdul Sadar, Computer System Engineering. Dr. Zakabano, Mathematics. Dr. Irfan Wright, Education and Dr. Shafaman Khan, Physical Education Department.
So the query was asked from the robot that please tell me the names of the HODs available at Sukkur IBA University. So this is how our robot showed the information about that. And there are multiple queries those can be asked from the robot, and the robot will be replying. And these queries will be related to information of the faculty available at Sukkur IBA University, about HODs, about scholarships available at Sukkur IBA University, about library, ERC, and MRC services available at Sukkur IBA University, and about foundation programs, induction programs, admission processes, announcements, and multiple departments available at Sukkur IBA University. All queries can be entertained from this robot. Moving ahead. So these are the samples of how faculty information is displayed. And this is again the third sample given from our robot that is about the providing information about university. So as I had told you that our robot also entertains queries related to scholarships available at Sukkur IBA University. So here is the National Talent Hunt program that is displaying. And in third screenshot, it is displaying about the information of university. So again, here's the video sample that we can see. There will be query asked from the robot, and the robot will be replying accordingly. Tell me about Sukkur IBA.
The Sukkur Institute of Business Administration is a public sector degree awarding institute approved by Higher Education Commission and chartered by the government of Sindh. Do you want to know more?
Yes.
Lead Professor Nizar Ahmed Siddiqui is founder of this university. In 1994, the Sukkur Institute of Business Administration was established for business education. Initially, the higher building of public school
So this is how the robot was displaying was entertaining the query. The query was simple about tell me about Sukkur IBA University. So the robot was telling the information, and if sometimes to any query, if the response is much larger of 10 to 5 lines, then the robot will not be reading all those 5 lines in just one pace. So it will ask user if the user is getting bored or if the user doesn't need much information about something about his or her query. Then the robot will be asking that if you do you want to listen more. If user says yes, then the robot will proceed. If user says no, then the robot will stop and entertain another query. I think that is a special functionality that we have implemented in this robot. So let's move ahead. So now these are the tasks about face detection and face recognition. These are the main tasks about the robot, that how robot learns the face. First it detects the face, then learns the face, and how does it recognizes the face, and then greets the person with his or her name. Actually, there is behind machine learning algorithm, we can say bridging, that is similar to KNN. Based on that, this robot is able to perform this task. So how this algorithm is working is that first face is detected and then face is recognized. And once the face is recognized, then based on programming logic, the robot is able to welcome, make salutation, greetings to the person or visitor based on his or her name. So actually, this slide is about how robot is able to learn the face. So simply simply there is face information. So what we mean by face information? So here are the main arrays, or we can say the variables available. Alpha and beta, these are the locations of the face appearing in camera angles, and size X and size Y depict the size of the face appearing in camera angle. And there's also extra information needed for face learning. What is that? There's a face ID. Based on it, we store the face information in the database, and there is a score recognition. This is kind of threshold. We can say the accuracy ratio of recognizing a particular face. And here's also face label, and this is the name of the person whose face is recognized or face is learned. And there's also other information such as eye points and also nose points and also mouth points. Based on these things, the robot learns the face and then recognizes it and then greets or welcomes the visitor accordingly. So as we said that it learns the eyes. So what does it learn from the eyes? As we can say that it learns eye center X in x-axis, eye center Y in vertically, and also eyes from the nose perspective. Nose size, side limit X, and also nose side limit Y, means these are the things that it is learning. And again, from nose points, it learns nose center limit X, means in x-axis and also in y-axis, and also from bottom side and bottom left and bottom right. Actually, this is taking pixels from the face, and also mouth points such as limit X, limit Y. These are the variables of learning particular thing from different perspective or dimensions. So this is how robot is able to learn the face. These are our results, simple outputs. So let me show you how actually it's doing this job. So this is first person Shakir, and he is sitting before a robot, and robot through its camera is learning his face. Let's see how.
Learn successful.
So I actually took 5 to 6 seconds to learn a face, and when it starts learning, it gives notification that start learning phase is starting. And once it is recognized, it also gives notification that face learned successfully. And here is another output that we can see is of Muhammad Deen, means me.
Learn successful.
So this is again, he learned my face. It took 5 to 6 seconds to learn a face. And once face is learned, then same person, if comes before a robot, the robot will be able to greet that person accordingly. So in second slide, I'm showing you that once the face was learned, then if the same face is appearing before a robot, then how the robot will be able to recognize that person. So this is how, again, I'm showing you that how this robot is recognizing a face. First video.
Can to recognize face. You are Shakir.
So first the face was learned and the label was named as Shakir. And if Shakir is appearing before a robot, then the robot is able to recognize that face and says, you are Shakir. So let's see another sample.
To recognize face. You are Din.
So this is how he recognized my face. So he says, you are Dean. So this is American accent that is not normally interpreted. So I was first, it learned my face and I was sitting before it. So it recognized my face and says, you are Dean. So we can write multiple responses as you are Dean is not a fixed response. They can be, hello, Dean. How are you, Dean? How do you feel today, Dean? Means with the name, my name, Muhammad Dean. How do you feel? We can say Amir or Ali. How do you feel, Ali? There, once the face is learned, we give a label to that face and that label is person's name. So whatever the name can be, and the if same person appears before a robot, then the robot will be able to call that person with his her name. Let's move ahead. So this is another second sample that was given to us in the comments that if a robot is able to recognize the face, then the robot should proceed one step forward. That is about detecting the gender of the person. If person before it, if it recognizes the face and greets with his or her name, the robot should be able to detect the gender and reply accordingly based on gender. If there is male, then the robot should say hello, sir, and if there is female, then the robot should say, hello, ma'am. So based on gender, it should make salutation or load certain conversations. So we did this successfully, and here the sample that I'm showing you. So the first sample is about Sir Rashid. This is employee available at Crab Lab. So he's sitting before a robot, and the robot is able to detect the gender of this person and greets accordingly. So let's have a sample before.
Hello, sir.
So this is how this person appears before a robot and says, hello, Pepper. Hello, robot. Or simply says, hello. So then by saying that the robot comes into action and recognizes person's the face, and based on that, it makes prediction if the person is male or female. Then accordingly, it loads the conversation. So let me show you another sample. That's about female.
Hello, madam.
So this is how if there is female, so it says hello madam, and if there is male, it says hello sir. So this is third sample of based on multiple faces.
Hello, madam. Hello, sir. Hello, sir.
So this is how our robot is able to detect the not only detect the faces and recognize the faces, but it's also able to detect the genders and respond accordingly. So this is how you saw that if there is male or female, then the robot greets or makes salutation accordingly, loads conversation accordingly. This is just a sample to show you that our robot is capable of doing this task. So let's proceed further. So yes, this was also a comment given to us by our evaluator that if robot is able to recognize the faces and to detect the gender, so robot should also be able to detect the emotion of a person that is standing before it, and it should make conversation accordingly. This will make it more user friendly and more humanoid behavior. So we accomplished this task too. Our robot is not only able to detect the faces, recognizes the faces, and detect the genders, but it's also capable of detecting the emotions. If person is sad, happy, or angry, or we can say amazed, then the robot is able to detect the emotion. So here's the sample that I would like to show you.
You look sad. Your mood is happy. You look sad. You look sad. Your mood is happy. You look sad. Your mood is happy. Your mood is neutral.
So this is how a person sitting before a robot changes emotion, and the robot is able to recognize the emotion and reply accordingly. If the person is happy, robot detects the face and detects if he is happy or she is happy, then robot replies accordingly. And if it is sad, then robot will ask why you are sad, what makes you sad, or certain conversation will be loaded in the robot. Let's proceed further. So now the fourth task that was about speech recognition, the main task. So let me tell you how actually this is working. There is first speech listening, means of course the person will be speaking with the robot, then speech listening, and then speech averaging using internal API, and there is the response accordingly. So these are the main three steps through which we are able to achieve this task. And these are three major high level steps, and how what we have achieved in these three steps I will be telling you further in next slide. So this is how the first step is that a person speaks with the robot, that there is done through voice to text conversation is done, and once whatever the person has said, it's converted into text, and then the text is analyzed. So what we mean by analyze, it means whatever the visitor has said and what is the query, what is actually the query is, and how robot should reply. So these are our three screenshots that we have displayed. In the first, confidence level, let me tell you what is the confidence level. See, whatever you have said, first it's converted from voice to text, and the robot is able to analyze the data that what is actually visitor asking or the person is asking. So if you have said, how are you, robot? So it's not mainly that robot will understand whatever you have said. For a robot, it's nothing. Whatever you have said is converted into text, and from the text, it is able to analyze. If you have said, "How are you, robot?" it may misinterpret it as why you are robot. What is robot? There can be multiple instances that robot may interpret it wrong. The query may not be well sound enough, or there may be a noise mixed with your voice, and that is feed it to the robot, and the robot may not come up with the same or the exact query that you have asked. So there comes confidence level, as robot may get multiple signals besides your signal that we can term as voice. There can be also noise, and there can be multiple voices coming from the environment, but for the robot, which voice should be recognized? So there is confidence level. Whatever robot hears from the sensors, these all signals are achieved, and these are filtered, and the signal with high frequency is the main signal that the robot focuses on, and that signal with a high frequency we can term it as the confidence level. So each signal is given certain threshold, certain confidence level, and the signal with higher confidence level is termed as the real data, the real query, and based on that, the robot analyzes the signal and responds accordingly. So what if you set confidence level at a 60%, so that means the signal achieved must have the confidence level of a 60. If that signal, if even if it is real, but if doesn't have the confidence level of 60, the robot will term it as noise signal, means not wanted signal. If a noise has a confidence level of a 60, then the 60 or above, then the robot will say yes, it is the real data that it has to analyze, and it is the real data that the robot has to respond it accordingly. So setting a confidence level too high will demean your original signal. Robot will consider all voices as a noise. And if you set confidence level too low, then the robot will give importance or give value to all the signals achieved, and the robot will not able to answer that which is the real question or which is the real signal that it should respond to. So setting confidence level or tuning it at a certain point where it should not consider all the signals as a noise, and it should not consider all the signals as a meaningful signals. So at a certain point it has to be. So what we did is to set this confidence level at a certain point where robot should be able to recognize a particular voice, a particular data, even with the local accents, and it should consider it and respond accordingly. So what we did first, we set it to 0.3, what we can say it a 30% confidence level. So at this level, the robot was giving importance to every query, whatever signal it was getting, it was giving importance to every query, and it was not able to recognize the main query that it was asked. So here you can see I have asked multiple queries that such as tell me something about department, so it has misinterpreted and it's understanding something else. Whatever I have asked, it's to one query or two queries it has responded correctly, but to many queries it is misinterpreted and it loads conversation misinterpretedly. Such as if you ask from me, what is your name? I consider this query as what is my father name, or what is my mother name, or what is my brother name. So this is misinterpretation. This is not real answer to a question. So at a second point, we set this threshold level at 0.4, or we can say 40%. So at this point, the robot is able to recognize whatever you are saying. So here it is giving, it is able to recognize more voices, such as if I have asked 10 queries from the robot, then in this level, the robot is able to entertain my 8 queries, and it rightly interprets my queries. And if I set it to 0.46, now here, this is the main point at the peak level, at the maximum level. This is the threshold where robot is able to give maximum accuracy. It doesn't consider all the voices as a noise, and it doesn't consider all the voices as meaningful voices. So this is the peak level we can achieve. Means if we say 10 questions, ask 10 questions from the robot, then the robot is able to entertain our 8 queries. So this is how we have achieved this level. So here are certain implementations. These are the implementations of how what our code looks like. These are the chunks of the code, blocks of the code. Inside these blocks, there is big coding, a Python script. This is again core blocks. We are using choreograph IDE. Inside that we have coded this robot. So whatever future directions, there are several areas of the improvement in this robot. One area of research is to develop more advanced sensors and actuators to enhance the robot's physical capabilities, such as mobility and manipulation. As I had told you that the sensors, those are fitted in the robot, are not highly advanced. So there is area of improvement that we should fix a high definition camera and high tactile sensors. Those could interpret the environment, those could interpret the touch on its body parts, and high definition highly advanced cameras for its mobility and manipulation. Another area of search is to improve the accuracy of robots' speech recognition and facial recognition technologies. As I told you that robot is able to listen the voices from the environment or from the user and respond accordingly, but it is not well enough that it could recognize or could give accuracy at 99%. So we need certain highly advanced sensors so we can improve the accuracy of speech recognition. So we need high definition cameras to increase the accuracy of face recognition technologies. And there is also third area, that is research is being conducted to develop more sophisticated machine learning algorithms to enhance the robot's emotional intelligence and make it more adapted to different user contexts. So we can also work on machine learning algorithms to develop certain machine learning algorithms where such a low definition images should be fed to these algorithms, and the algorithms should give accuracy at the maximum point, they should be able to recognize force at the highest accuracy. And also, if we feed that voice data, audio signals in the algorithm should be able to recognize the voice finely and respond accordingly with highest accuracy. So this is it. Thank you from our side, and we have presented our presentation successfully. Thanks for listening us.